Okay, so now let's talk about remote computation. So what is a compute cluster? A compute cluster is a series of computers that are stored somewhere else, in our case at Boston College, that you can connect to and use those computers to store your data and to run your analyses. Using a compute cluster has at least two advantages. One is computational power. The computers stored there usually have more RAM, more storage, and maybe a GPU that the laptop you're using might not have. And second is convenience. Instead of using your laptop to pre-process data and run analyses for a long time, you can just send it off to the cluster and it computes there, maybe for a day, maybe for a week, and then you can get an email notification back when your job completes. So how do we use a cluster? Well, once you have an account, once you're a registered user, you can log in to the remote cluster using SSH. So you would type in SSH, and if you're connecting from outside of Boston College, you specify a port and then your username. If you're connecting from within Boston College, or if you're using a Boston College VPN, you can skip the port specification. So it would be just SSH and your username. It might ask you for a password, and once you enter your password, you're logged in. And once you're logged in, you can use the terminal as you would on your local machine. So you can use commands like pwd to show the path. You can list the contents. And you can make directories, launch scripts, use it as you would your own machine. Now, by default, when you log in, you're connecting to what's called a head node. So a compute cluster consists of a head node that controls all of the individual compute units. So when you log in, you're initially in this head node that everyone else who connects to the cluster is also on the head node. So you don't want to do any heavy analyses here, because if you start launching computationally heavy work, you will slow down the cluster for everyone else. So if you want to do anything that's heavier than, let's say, editing text files or making folders, you want to request a compute node. To request a compute node, use the following command. Here you specify the name of the job you want to run. That is optional, something silly. And you specify the parameters of the compute node that you want. So here I'm specifying that I only want access to one node, one processor. I want it for 6 hours. I want 16 gigabytes of memory, and keep this as a default so it launches bash. And once you click enter, you see that I changed from being on the head node to a compute node C050, right? And here I have a computer allocated to me with these resources, and so here I can do any kind of analysis that I want. Now, because this is an interactive session, if I were to launch a script and then exit out of the terminal, the session would end and my script, whatever analysis I was running, would be canceled. So these interactive sessions are good when you want to do something on the fly, when you want to, let's say, move some files around, or if you want to debug a script and things like that. But what if you want to launch a job that will run for a week? Let's say you want to pre-process 1,000 brains or something like that. You don't want to have to maintain a connection for a very long time. And so for that, you can submit a job, and we'll see how to do that. So to submit a job, I will make a text file with instructions of what the computer needs to do, and then I will send it to the queue. To do that, we can use Nano, and let's give the job a name. And here I will copy over some stuff that I had. So your job description should start with these commands. These tell the scheduler what parameters you want before it executes whatever job you specify. So that includes things like what name to give the job, where to store the output. So sometimes when you run code, it produces some text output that you would normally see in the console, but if the job is running somewhere on a compute cluster, obviously you won't see that. So if you're submitting a job, all of that output will be saved for you in a text file. And this is where you specify the name of that text file. So this is also the same parameters that we saw before. For how long do you want the job to run? So for example, if you have a job that you think will run for about 8 hours, you can request around 10 hours of compute time. So give yourself a little extra time, because whether or not your job has finished, if you max out the time you specified here, your job will simply be canceled, right? However, if your job finishes before this elapsed time, it will also stop once the scheduler recognizes that all of the commands it had to run have been run. It will also terminate the job. So be sure and give yourself some extra time when you're specifying here. This is where you specify memory per CPU. Leave it as a default unless you need to change it. And you can also specify your email here so that once you send the job to the queue, you will get an email notification when the job starts running and when the job finishes running, and if it encounters some sort of an error. So this is a really good way to monitor your work. And once you specify this preamble, you can then enter your commands, whatever work you want to run. So this can simply be a quick line pointing to some sort of a pre-written script that you wrote that you want the scheduler to run. So in this example, what we want the job to do is to echo hello. So this should be stored in the output. Make a new directory and then run a simple Python script. So if we save this as a text file with all of the instructions that we want the scheduler to do, and then we simply use sbatch command, specify the name of our job, and we press enter. And this submits the job to the queue, and you're just waiting for your job to run. So there are other useful SLURM commands. For example, if you want to check what's in the queue, you can type in sq, and this will show you all of the jobs that are currently running. So here we have our interactive session here, and the job that we submitted, I just got an email notification that it finished running. If at any point you submit a job and you want to cancel it, you can use sq to locate your job. You copy the ID, and then you use scancel, specify the job ID, and then it stops. How to copy files in and out of the cluster. What if I want to put some files on the cluster? And what if I did some analyses on the cluster that I want to download to my local machine? To copy files locally, you would use CP. To copy files over a network, you use SCP, which stands for Secure Copy. So let's say I want to download this SLURM tutorial folder on my local machine into this My Stuff folder. I would use SCP, then I specify the full path to the remote file, which includes my login credentials and the path to the folder on the cluster. And as a destination, I specify simply the local path of where I want the folder to get to. In addition to that, if I'm copying files from the cluster or to the cluster and I'm not in Boston College or using Boston College VPN, I have to specify a port, similarly to when logging in. So I specify the port. And additionally, if I'm copying over a directory instead of file, I add a -R flag. If you're copying a file, you don't need it. With that done, I press enter. And the folder is copied, but it's stored it on my desktop. Here it is. And as the last thing, let's talk about how to launch a Jupyter notebook that is running on the cluster. So for that, you need to first you need to log into the cluster and request an interactive node. We've already done those two steps, so we can skip them. And then you want to open up a notebook on the cluster first. For that, you use this command. And as IP, you specify the IP address of the compute node that you were allocated. You can specify any port number you want, but this is a good default. You click enter, and now you have a Jupyter Notebook kernel running on the cluster. So now you want to connect to it from your local machine. For that, use this command to set up port forwarding. Make sure that the ports you specify here match the ports used to open up the notebook. And here, you use the same IP that you used when opening up the notebook. As the last thing, you include your login credentials and you press enter. Once you see that it's running, you open up your browser, you type in localhost, followed by the port that you specified. This opens up an interface, a Jupyter Notebook interface, that is hosted on the cluster. So here you can browse files that I don't have locally, they're on the cluster. And when you perform analyses, it's also using remote computational resources. But otherwise, you can use it just as you would use a notebook that is running locally. So this is pretty useful. It simplifies a lot of things. You can navigate through folders, and you can also download files pretty easily.